must sum to 0. If we substitute in the known values for the forces of negative 200 pounds for LDY, negative 200 pounds for LEY, and the unknown force RBY to equal 0, we can determine that the force RBY is equal to positive 400 pounds. Since joint E is one of the simplest joints, having only one external force and two members, we will analyze it first. Once again, recalling that any force can be broken down into an X and a Y component, we can determine that the force LE can be broken down into LEX, which equals 0 since the force is applied vertically, and LEY of negative 200 pounds. The force EC can be broken down into an ECX and an ECY of 0. This is occurring because that member is horizontal. Finally, the force ED can be broken down into an EDX component and an EDY component, both of which are unknown at this point. Since only one of the forces in the y direction is unknown, we will find the force EDY first. Recalling again, the sum of the forces in the y direction is equal to 0. Thus, the force LEY, the force ECY, and the force EDY must sum to 0. Substituting in our known values for LEY and ECY, we find that the force EDY is equal to 200 pounds. To find the force EDX, we know the force EDY, we know the angle at which it occurs of 56.31 degrees, and we can then determine the force EDX. Thus, the tangent of 56.31 degrees is equal to 200 pounds divided by the force EDX. Isolating that force, we find the force EDX to be equal to 133.33 pounds. Now that we know both components of the force ED, we can determine the force along the member. In this case, the sine of 56.31 degrees is equal to the force EDY divided by the force ED. Substituting in the known values of 200 for the force EDY and 0.83 for the sine of 56.31, we can determine the force ED to be equal to 240.37 pounds. To apply the force in this direction, the member needs to be in tension. The next step is to find the force ECX, thus the force along this member. Once again, we use our static equation. The sum of the forces in the x direction is equal to 0. Now the forces will get solved. The force EDX plus the force ECX plus the load force EX must equal 0. Substituting in the values for the forces, we find that the force ECX must be the opposite of the force EDX. Substituting in our known value for the force EDX, we find that ECX is equal to 133 pounds. To apply the force in this direction, the member needs to be in compression. Next, we will determine the force along member CD. Recalling again that the sum of the forces in the y direction is equal to 0, we can sum the force CAY, the force CDY, and the force CEY to equal 0. Since CE is horizontal, its y component is 0. Since CD is vertical, it has an x component of 0. Thus, we can determine that the member CD carries no load. Continuing to solve our truss problem, we will determine the force along member CA. Recalling quickly that the sum of the forces in the x direction is equal to 0. At point C, the sum of the force CDX, CAX, and CEX must equal 0. Substituting in our known values for the force CDX and the force CEX, we can determine that the force CAX is equal to 133 pounds. Since the member CA is horizontal, its y component is 0. Then the force along the member CA is equal to the force in the x direction of 133 pounds. To apply this force at point C in the correct direction, this member must be in compression. Next, we will find the forces occurring along member BA. Recalling that the sum of the forces in the y direction is 0, the force BAY plus the force BDY plus the reaction force RBY must equal 0. We know the force BDY and the reaction force RBY, thus we can isolate the force BAY. It is minus 400 pounds. Since the member BA is vertical, it has an x component of 0. Then the force BA is equal to the force BAY of minus 400 pounds. To apply a force in that direction, this member must be in tension. Next, we will analyze the forces in the member BD. Recalling that the sum of the forces in the x direction is equal to 0, the force BDX plus the reaction force RBX must be equal to 0. If we substitute in our known value for RBX, we can find FBDX to be equal to 666.67 pounds. Since the member BD is horizontal, it has a y component of 0. Then the force along the member BD is equal to the force BDX of 666.67 pounds. To apply the force in this direction, the member needs to be in tension. The final member to analyze is the member AD. Noting that the cosine of 53.13 degrees is equal to 400 pounds divided by the force along the member AD to be equal to 667 pounds. To apply the force in this direction, the member needs to be in compression. At this point, we have completely analyzed all the forces occurring on the truss and within the truss. In addition, we have determined all the dimensions of the truss and the appropriate angles.